Okay guys, here is a video on 4-7 because in class we got a little crazy. So again, arc just means inverse. When you say arc sine, that means the inverse of sine. It means the opposite. We're looking for the angle is what we're doing. For sine, the domain is -1 to 1 and your range is negative pi over 2 to pi over 2. So if I say arc sine of x equals y, whatever number is here, we have to make sure it's in the domain from -1 to 1. Whatever number is here equals to on the y, we have to make sure it's in between negative pi over 2 to pi over 2. So if we look at A, what is the arc sine of 1/2? So that's like saying arc sine of 1/2 equals y, or it really equals theta, but we'll call it y for now because we think of domain and range in terms of x and y. This is your x. Is -1/2 in between -1 and 1? Yes, it is. So we can do this problem. Once we've figured out that it is between the proper boundaries, then we can draw a picture. Sine negative is going to be down here or down here. And if my y, which is sine is just y, so my y length is 1/2. So this has to be a 30 degrees because 30 degrees is across from 1/2. Well, the reference angles are 30 degrees, but this total angle here in quadrant 3 is 210 degrees. And this total total degrees in quadrant 4 is 330 degrees. And we can write those in radians. So 210 degrees in radians is 7 pi over 6. And 330 degrees in radians is 11 pi over 6. Now, neither of these, this would be your y or your theta, 7 pi over 6 and 11 pi over 6 do not fit in between negative pi over 2 and pi over 2. However, you can write them as the negative. So 11 pi over 6 is really negative pi over 6. And 7 pi over 6 is really negative 5 pi over 6. I'm going to put that up here. So negative 5 pi over 6 is bigger than, or is more negative than negative 1/2. So that doesn't fit. But pi over 6, negative pi over 6 does fit. So this is our answer. If you look at B, sine inverse, which is the same thing as arc sine, you can write it either way, equals root 3 over 2. That's your x. Does root 3 over 2 fit in between -1 and 1? Yes, it is 0.86, so that does fit. So we can go ahead, draw our picture out. Sine is positive in the first or second quadrants, and across from the root 3 over 2 is 60 degrees, and 60 degrees is pi over 3. And we can just stop there because in quadrant 2, it's going to be 120 degrees, which is 2 pi over 3, and 2 pi over 3 does not fit into our range here. If we look at C, 2, that's your x, don't forget. 2 does not fit between -1 and 1, so we can write that it does not exist. Because again, we have to keep track of our domain and range because of our 1-to-1 ratio. The arc sine graph is only this portion of the graph if the graph was to continue to go further. So we can continue on, talk about cosine and tangent, which we approach the problems the very same way as sine. The only difference is your boundaries for domain and range. For cosine, domain is still the same, -1 to 1, but your range is from 0 to pi. So that's a difference between cosine and sine. For tangent, your domain is -infinity to infinity. So that's a difference. And then your range is -pi/2 to pi/2, just like sine. So they all have one thing in common with each other, and then they'll have a difference. So we want to remember, for cosine, domain -1 to 1, range 0 to pi. Tangent, domain -infinity to infinity, range -pi/2 to pi/2. And we can solve these the exact same way. This is my x. So my x is my domain between -1 and 1. And yes, √2/2 is between -1 and 1. So we can go ahead and do this. Cosine is positive in quadrants 1 and 4. And across √2/2 would be your x value. I drew a really small triangle, so I'm just going to draw a little arrow. And that's a 45-degree angle. And 45 degrees in radians is pi/4. We can double check that. Is pi/4 in between our range of 0 to pi? Yes, it is. So, oops. This is our answer, pi/4. If we did this bottom one here, we would get 7 pi/4 or -pi/4. 7 pi/4 is over 1 full pi, and -pi/4 is less than 0. So that quadrant would not fit into our range, which is why it has to be first quadrant pi/4. If we look at B, tangent of -1, well, this is our x, and our domain for tangent is -infinity to infinity. So is -1 a real number? Yes, it's a real number, so we can do this. So we would say draw a picture. Tangent is negative in quadrants 2 and 4. Tangent is y/x, right? Or sine over cosine. So anything over itself is 1. So to get 1, we have to have the same number over itself. At 45 degrees, sine and cosine, or x and y, are the same because it's an isosceles triangle. So I know that this has to be a 45-degree angle. And same here. So this is a 3 pi/4. And this is a 7 pi/4 in radians. For tangent, your range is negative pi/2 to pi/2. That's for your y, your range. So 3 pi/4 is bigger than pi/2. And 7 pi/4 is bigger than 5 pi/2. So let's check the negatives. This would give me a negative pi/4. Negative pi/4 is bigger than negative pi/2, so that would work. This would fit into our range. This would be negative 5 pi/4 if we did the negative of our second quadrant, which would not fit in our range. So it's got to be negative pi/4. Okay, let's look at our last example, C. Check your x, right, what this is. Does it fit in our domain between -1 and 1? Yes, it does. So we can go ahead and draw a picture. I'm going to try to draw really big triangles for this one. So I know that this side here is -√3/2. X is negative, or cosine, which is x, is negative in quadrants 2 and 3. So across my √3/2 has got to be a 60-degree angle. So then these reference angles have to be 30 degrees. So the reference angle is 30. So this is 150 total degrees. And this would be 210 total degrees. And 150 degrees is 5 pi over 6. And 210 degrees is 7 pi over 6. So these are potential y's, right? Those are our answers. And we have to remember our range for cosine is 0 to pi. So which one of these is between 0 and pi? That would be 5 pi over 6. So that is our answer. Okay, so moving forward from here, this is where I think things got really confusing. There was a typo, and what it should have been is the arcsine of sine y equals y, and the sine of arcsine of x equals x. I had x and y switched here, which is why I think you guys were getting confused with the domain and range, and then I wasn't understanding because I didn't realize I had switched the variables. So I apologize for that. So this is the correct way. Arcsine of sine y equals y, because arcsine and sine are opposites, or inverse sine and sine are opposites, so they will cancel out. Assuming that your variable fits in between your domain and range. Cosine of arc cosine will cancel out, and the arc cosine of cosine will cancel out, and you're just left with your variable. So as long as your variable is within your bounds, then these are super nice and easy. We can always say arc, we'll deal with sine. Arc sine of x equals y, and sine of y equals x. And this helps me, and this might help you to differentiate between when to check for domain and when to check for range, right? Y range, x is domain. So if we look at arcsine of sine of 3 pi over 2, this is your y here. This is your range. 3 pi over 2 is outside of the range, so this doesn't work. If you forget to check, we could look at it and say, oh, well, sine of 3 pi over 2 is -1, and the arcsine of -1 is negative pi over 2. Because if we look at sine of 3 pi over 2, that's 270 degrees. That's this point right here, which is 0, -1. Which is how I know that sine of 3 pi over 2 is -1. And then we could say, okay, if we look at arcsine of -1, at one angle is sine -1. That would be 270 degrees. Or 3 pi over 2. But 3 pi over 2 does not fit, so we can write it as negative pi over 2. So negative pi over 2 would be our answer, but negative pi over 2 is not 3 pi over 2. So that's why it won't work. Really, because we can check, if we check the domain and range first, we can see that this won't work. So let's check the possible values. I'm going to give us some more space here. For A, the arctangent. So if it's arctangent, then this is going to be x. And our x, our domain for tangent is -infinity to infinity. And -5 is definitely in between -infinity to infinity. So we can cancel these out, and our answer is -5. So this is the end of the first video. We'll finish up these last few problems in part 2.